Hello. Good morning, everybody. No, wait. Good afternoon, everybody. Start that over. Thanks for coming out to the last session of the day. I hope you're having a good conference. Are you? Oh, that was enthusiastic. Good. So a while ago, I did a series of code reviews on a number of services and applications that I was helping to build with a company, and was taking some notes about things that I liked and things that I didn't like, and I came up with a list of 68 items to review with the team. And I thought, well, maybe I could make a conference talk out of this and cut out some of the smaller issues or company-specific issues. And that's what I want to come to share with you today. So talking about building ASP.NET Core applications, I assume you already have some familiarity with ASP.NET Core. So I just have a series of tips that I want to walk through, opinions. I'm not talking about best practices. I'm just talking about the things that I like to see when I'm in a project. And the tips I have are broken up into solutions and projects, startup code, writing controllers, writing client code, writing C# code, views, and testing. Let's talk first about setting up solutions and projects. One of the interesting things, well, there's several interesting things that happened when Microsoft decided to go open source with ASP.NET Core and .NET Core. One of the interesting things is not that we could get to the source code, because we could always get to the source code for stuff in .NET. We could use some sort of decompiler. So what was really interesting was the ability to go into a GitHub repository and see, first of all, how Microsoft would structure a solution and how they would structure their repositories and how they would lay things out on the file system. And it was also interesting to read through the samples and experiments that they would check in alongside of the production code. And it's also very interesting to me to read through their unit tests, particularly if I'm trying to understand how something works. So there is a consistency in the Microsoft repositories when you look at them across all of ASP.NET Core and .NET Core and how they structure things. And I quite like that consistency, and I quite like the model that they use. So first of all, you go to any Microsoft source code repository, and in the root of that repository, which is not present on this screen, but what you would see is, first of all, the solution files in the top level. So anyone who is using Visual Studio can clone the repository, and it'll be blinking up there also. Yes. No, still blinking. I touched it. All right, don't breathe. No. I'll keep talking while someone figures something out. Just try not to look too hard at the screen and become nauseous. Where was I? Yeah, there's a .sln file in the root of the repository. So a Visual Studio developer can just clone the repository, double-click on the solution file, and they can start working with the code. But what you also see inside of every repository is there's always a source folder in the top level of the repository, SRC, that'll contain the production source code. There's a test folder, so all the unit tests are in one place under that folder. Typically, there's a samples folder. So if the repository is a repository for anything like a framework that's going to build a NuGet package or something that provides an API that people are going to consume, then inside of that samples folder, you will quite often find some very interesting applications of this particular technology. So when I was trying to figure out how authentication and authorization worked in ASP.NET Core, one of the places that I found most useful, much more so than the documentation, was the samples folder that's in the ASP.NET/security GitHub repository, because they would just write some low-level code demonstrating how a specific feature would work at a very low level. All right, we're going to try some duct tape. Okay. So I'll talk about some of the other folders that you typically find at the top level. One of the things I like to include is a documentation folder. So there's a picture of a solution that actually has a folder in it called Docs, and with our team members, we can check in information and documentation that people might need to run this project or to understand the architecture or to understand the components. Now, the trick to this, as you probably know, the Visual Studio Solution Explorer window that is pictured there tells a total lie. It does not give you a faithful representation of the file system behind this project. So when you try to right-click a solution and say add a new folder, you're not adding a folder on the file system, you're adding a virtual solution folder. And when you put stuff inside of there, it doesn't exist in that folder on the file system. So the trick is, in Visual Studio 2017, and some people might know this, there's this little icon in the action bar for Solution Explorer that toggles between the solution view and the folder view. And when you switch over into the folder view, you do lose some capabilities, but you also get a faithful representation of the file system. So click on this, and now when I'm trying to make sure that files I place on the file system are in the correct place, and I right-click and say things like Add Folder, I know that's actually going to happen on the file system. What I lose is, that upsets some people, when you right-click on a folder, you don't get the ability to do things like manage NuGet packages, but to me that's okay, because it's simple to toggle back in here or just do it through the CSproj file. Some of the other things I like to check in are, in addition to samples, any tools that you might use during development on a frequent basis. So command line tools and scripts. In fact, scripts are something I like to check in. And this is just a picture of the ASP.NET Security GitHub repository with their samples folder. So if you want to look at something at a low level, like how cookies work, that cookie sample is great, because otherwise you're trying to figure out things while working through ASP.NET Identity Framework or working through an OIDC piece of middleware in the services. That cookie sample is just straight up app.run middleware that shows you the two most important lines of code to work with cookie samples. The first line of code is creating a claims principal, and the second line of code is calling HTTP context.signin async and passing that principal in with the cookie scheme. And that just running that sample and seeing cookies being issued is everything you need to know. So hopefully this is making sense. I also like to check in development scripts. So now that .NET Core has command line tools and command line utilities that provide a lot of useful features, then the more that developers can do use command line scripts to automate tasks in a repeatable manner, the better off we are. So I like to check in scripts that developers will use on the project on a regular basis. So if you're using Entity Framework and you want to add a migration and you want to make sure it happens in a consistent manner, then maybe add an add migration script that will do .NET EF migrations add and .NET EF database update. If you are working in some sort of cloud environment, I'm also a big fan of checking in either scripts or templates or something that codifies and automates the provisioning of resources. Because ideally what I want to happen is, a new developer is on the team, they'll do a clone of the repository, they'll go in and maybe fill out a few parameters, maybe just enter their developer name and then run a script, and poof, something inside of Azure appears. There's an app service, there's a key vault, there's a SQL database, all of that's just provisioned and all the correct settings are there to start working in development. And it's the same scripts that you can parameterize to set up the QA environment and the production environment and the load testing environment, so everything is consistent. For Azure, Visual Studio has the concept of a resource group project, which is where you can add ARM templates, which are the JSON files that contain all the properties of a particular Azure resource. They can be a bit frustrating to work with in my experience. Sometimes it's easier to use the Azure CLI and just write imperative code to say, go out and create this app service and then add these 3 app settings. Sometimes that's a lot easier. When it comes to online builds, there's 2 build systems that I'm familiar with. One is using AppVeyor and one is using Visual Studio Team Services. Both of those systems try to be very helpful by giving you a UI where you can describe your build. So for example, with AppVeyor, I can log in and I can say, here's my source code, and I want to run this task, and VSTS is the same. You drag and drop tasks into a UI to describe how you want to do a build. The thing that drives me nuts, though, is when those builds don't work, when you're trying to troubleshoot something, when there's a npm install command that's being executed during the build and it's happening in the wrong directory. It's really difficult to figure out why that is. Fortunately, both of those systems also allow you to get away from the UI and codify your build. So for example, with AppVeyor, if I don't want to use their UI, if I want to have more control, I can just check in and appvar.yaml file into the root of the directory. And inside of that appvar.yaml file, now I have all of the settings for my build, the top-level settings, and now they're source controlled, and I can see when someone changes something and it changes the behavior of the build or changes the artifacts that are produced. And as part of that YAML file, you can tell appvar what build script you want to execute, so perhaps a PowerShell script. .NET builds are typically pretty easy. I mean, there's a lot of ceremony here, but basically you do .NET restore, .NET build, .NET test, and .NET pack. And there might be some other things you need to add there with NPM and so forth, but that's the essence of it. Same thing for Visual Studio Team Services. They want to give you a UI where you drag and drop things, but it's the same steps we just saw, .NET build, .NET test, .NET publish, and then place my artifact somewhere. I would much rather go into the task catalog and add a task for executing a command line script or executing a shell script, or using something like a cake build or a Pisaki build that I actually check into source control, and then I can run those builds locally and troubleshoot them and tweak them, as well as run them in the cloud inside of VSTS or AppVay or something like that. And it just saves time, and I like having the configuration for the build in source control. All right, let's talk about startup code. So the interesting thing I noticed is when ASP.NET developers came to ASP.NET Core, they were looking for that place that allows you to write startup code. So in ASP.NET, we had the global.asax file, we had the application start event, and that was logically the place to put startup logic. That's where I wanted to put stuff that might have to prep the file system or migrate my database or run entity framework migrations, those sorts of things. Then when developers came to ASP.NET Core, I think they saw startup.cs, and I've just seen some of the most bizarre things happen inside of startup.cs. Everything from file system manipulations and database seeding and so forth. To me, startup is really just, these days, about two responsibilities. The first responsibility is configure services, and the second responsibility is writing configure. So one is configuring the IOC container or the service provider in ASP.NET Core. The second one is about configuring the middleware that you want to use. A lot of people who started with ASP.NET Core in 1.0 are also used to seeing a constructor for your startup class, where the constructor can have some services injected, and inside of the constructor you would set up things like configuration and your logger and so forth. Ideally, I would like to take that code out of startup.cs, put it into program.cs, which is where the static main entry point is for ASP.NET, and set up your configuration sources and your logging as soon as possible. So even rip that stuff out of startup, which leaves you with just configure services and configure. So I've also been on projects where you go into configure services to try to figure out why the application is behaving a certain way or see what services are rendered. And configure services can easily grow to a couple hundred lines of code, because once you start adding the MVC framework and adding some customizations for it, and you configure your OpenID Connect services, the authentication services, and add some configuration for it, everything just grows and grows and grows. What I like to do is come into configure services and just see a flat series of method calls that are extension methods that developers have implemented to add the services and all the customizations that they need. So I can see at a top level, oh, we're using MVC, we're using security, we're secure, we're using a thing called mediator I'll talk about later, we're adding some sort of data stores. And to me, it's a lot easier then to figure out where I want to go just by putting the cursor there and pressing F12 and digging into one of those things than it is trying to dig through 4 or 5 sections of blocks of code like this, which are just trying to configure the MVC framework. Same thing goes for the configure method when you're adding middleware to the application. Although I think, to me, it's okay to allow configure to branch. So I want it to be very explicit what middleware is installed during development, like browser link. I don't know why that's there. And what middleware is installed during production, the production exception handler. To me, that's important to see the difference between those two environments and how the application will behave. But in other cases, if you're passing in option objects into these methods, and those option objects are sort of garbling up the clarity of configure, again, I would like to write in a custom extension method to say, use MVC with custom options, that sort of thing, and pack that stuff away somewhere else. And then one of the beautiful things about ASP.NET Core is you're not just writing something that is a DLL that has to get hosted somewhere. You can, if you think of the application that you're building as a standalone console application, there's some interesting things that come out of that, I think. So going back to that discussion of where do we actually put startup code if it's not inside of startup.cs? Well, program.cs with its static void main entry point, that ideally is where I would like to see startup code. And there's this really interesting point in time, which is right about here, which is in between the time when I've created a web host builder and I've told it what it's going to use and what the startup class is. Between that point in time when I build it and when I start running and listening for HTTP messages, this is a point in time that's unique in applications for .NET, because at this point in time I can do things and I know my connection strings, I know my configuration sources, I know my logging. Everything's been set up for me. There's a service provider, there's a container that's ready to fetch services for me that have been configured for production. So it's at this point in time where I like to do some of the interesting things that might have to happen before the application actually starts listening for HTTP messages. So for example, if someone runs this with .NET Run and says .NET Run drop DB exit, what the application can do is come in and get an instance, in this case for this project, get an instance of the DB context that the entity framework will manage for the database and can drop the database, and then perhaps run the migrations that are in the project and perhaps seed the database with some of the sample data or the lookup data that has to be in place for the application to run. And then, in fact, we could even stop the application so it doesn't continue to listen for messages, because that's all we wanted to do. We just wanted to get the environment configured and make use of this application as an executable. And when you do this, instead of showing this code, I just want to point out that if you're ever working with the host.services and you're pulling a service out, you're trying to use it to resolve a service, particularly if you're outside of an HTTP transaction, you want to make sure that you go through an iService scope factory. Scope factory is something that can create a scope that's disposable. So when you're using the scope to resolve services, like so, give me a service, you can make sure that you're not doing something like accidentally creating a singleton out of something that was supposed to be transient, because everything will get cleaned up properly when that's done. And this is another script that could be checked into the scripts folder for the project. So a developer can just do a get pull in the morning, then run recreate DB, and this will do a .NET Run, drop the database, migrate it, seed it, stop, and they're ready to start working with any changes that were checked in the previous day. Project structure. Before I talk about feature folders, how many people know about feature folders, by the way? A few, I think. Let me give you a scenario. So I'm going to flip over to Web Applications 7 and 8. Very popular applications. They're going to go far. So I'll tell you this. Web Application 7 was created by saying, file new project, give me an MVC application that uses ASP.NET identity to allow users to register and log into my site. And when you do that, with ASP.NET Core 2.0 at least, what Visual Studio, what that template will do is generate all the controllers and all the views and all the models that you need to register users and to do two-factor authentication and reset passwords. All of that stuff is here on the file system. I also did Web Application 8, also with ASP.NET identity, but I did it with something called Razor Pages. So I just want to compare these two for a specific scenario. So let's say someone comes to me and says, Scott, the user is trying to reset their password and there's some sort of bug, we don't know what's going on, can you take a look at that feature, right? I want to think in terms of features primarily. So I want to think about, reset password. What do I need to do to work on that? I want to get all the files open so I can look at this. I'm guessing that might be an account controller. If the user's going to reset a password, they're doing something with their account. So let's go in here and start scrolling down, looking for reset. Well, there's login. There's register. We've been through 300 lines of code. It's not there yet. Confirm email. Forgot password. Reset password. There's the get, and there's the post. Okay, I'm 1/3 of the way there. I found the controller code that I need to look at. Now maybe I need to look at the views. Let me go into the views folder. I'm assuming this will be an account. There's reset password there. Open that file up. Now I want to find the models for this particular feature. So let me find the reset view model that the controller uses. And now finally, I have found the three primary pieces of the three primary abstractions that I need to look at to work with this feature. So what irritates me about this today is that the model view controller design pattern is about a separation of concerns so that the controller only knows about the HTTP request or some external stimulus. It builds a model. The model doesn't know about HTTP. It doesn't know about the controller. The controller sends the model over to the view. So there's this nice, testable, flexible abstraction. But the MVC design pattern never said that there had to be a separation of these abstractions so that they're in three different directories all over the place, right? I have a really actually difficult time working on MVC projects these days that use the conventional controllers are over here and views are over there setup. So previously, before ASP.NET Core 2.0 came along, I was really into feature folders. So the idea of feature folders was instead of putting controllers and views and models in separate places, you would instead organize these UI layer abstractions into folders that, to me, the way I like to work with it, these folders kind of represented the hierarchy of your UI. So if you have an admin menu that someone clicks on and then they click on a button to manage a season or manage invoices, whatever it is, everything about that particular feature would be inside of here. So there's the controller, manage season controller. There's a couple of views in here that the controller might render, and there's a couple models that the controller works with. So when someone goes to work on that feature, they have one folder to go to and everything's there. One day, I hope it's possible that I can actually place my unit tests inside of that same folder for the feature and actually have unit tests in the same project as the production code, but have some way to magically remove things or unlink them if I'm not going to run unit tests, but then everything's in one place. So for previously, before ASP.NET Core 2.0, I would use feature folders, and I actually built a little NuGet package. If you wanted to install it, all you had to do is install the package and then say services.addmvc.add feature folders, and now you could start putting views under the features folders. But then something interesting came around in ASP.NET Core 2.0, which was Razor Pages. So the second project, Web Application 8, is built with Razor Pages instead of controllers and views. So same scenario, me, the developer, wants to work on reset password. So let me come into the Pages folder, and I'm guessing, again, this is under Account, and oh, there it is, reset password. That's the feature I want to look at, so let me open the view. There's also the code behind file, which has the model embedded inside of it, but just 2 clicks, and I now have everything that I need to work on that feature. So with Razor Pages, there's not this artificial separation of here's the thing that is sort of like the controller and here's the view, and they have to live apart. They're right there together, which is kind of nice. And just to give you a few words about Razor Pages in case you haven't looked at them yet, I do enjoy them. They are the real deal. You're still writing Razor, so the Razor views aren't all that interesting. They're the same as any Razor view really that you would render from a controller for the most part, except it has an @page directive. But then a lot of people think of this as this code behind file and say, oh Lord, is there view state too? And the answer is no, there's no view state, there's no artificial synthetic click events, nothing like that. If I open up the page model for that particular view, this is very much like a controller. So you have dependency injection, so you can see there's a constructor where we're asking for a service to manage users. Yes, they define some of their models as nested classes inside of the page model, which I'm not a big fan of, but that's okay. I mean, personally, if it was up to me, I would probably put that in a separate file, and I would actually create a folder called register and or a reset password and tuck the reset stuff into there. So it's even a little more granular than just dumping everything into this one folder. But this is how I'm going to bind things. When the user posts a form back, it's going to bind to this input model. I can also use that input model when I'm binding stuff in the UI to display or binding inputs. And it responds to an HTTP GET request, and it responds to an HTTP POST request. So really, it's not that much different than a controller. And in fact, in some ways, it's a little bit better. This post request, you'll notice there's no attribute here to validate the anti-forgery token. That's because Razor Pages just assume you're going to be working with HTML forms, and every post operation should validate an anti-forgery token. So it just is taken care of for you. You don't have to worry about developers accidentally missing that. So if you haven't looked at Razor Pages, give them a try. I think they're awesome to work with if you're building HTML applications. But to me, if you're building APIs, you use controllers. But if you're building an application that primarily does server-side HTML rendering, I don't want to use controllers for that. I want to use Razor Pages for HTML. And then when it comes to controllers, please don't allow developers to use app.useMVC middleware with a route builder to define templated routes. Some of the worst API designs I've seen have happened when developers use the route builder to define templated routes. So I've seen APIs where there's a method that takes an ID parameter, and you actually look, and that ID parameter is something like an invoice date. And you ask the developer, why are you passing invoice date as ID? Well, that's what the template said. It said controller action ID. The third thing always has to be named ID. No. So the solution to that is not to use don't use the route builder at all, just use routing attributes, because now URLs are looking developers in the face. So they have to think about the URLs that they're actually putting together when they're writing controllers. So if this controller should be part of a collection of controllers that manage admin type resources, then it's really easy to say, yeah, let's tuck this into admin. And to do that, I don't have to go into some ugly route builder code and fight with other people that are adding templated routes there. So the other thing I can do is it's really easy to change my parameter name. So I don't have to, not everything has to be ID anymore. So this one is a season ID, this one is a match set ID. So I think the route attributes are the best way to go because they, again, force developers to think about the URLs that the clients are going to use to consume the API, which is good. And you can actually start thinking about resources, and especially you can think about the relationship between resources. How are they nested? Should something be underneath of something else? I wanted to change that actually, I forgot. Anyone use Mediator? Know what it is? Few people. I'll just say think about Mediator because it's not something everyone should use. It's really useful in some cases, but let me explain what it is. It's basically an in-memory service bus. Jimmy Bogart's the author of the Mediator library. It's an in-memory service bus. So what you can do is when a controller receives some input from the user or some request, it can translate that request into a message that is put into Mediator and sent off over the service bus to find something that will process that query or process that command to produce a result. So what it adds, like any messaging system, it adds a layer of indirection between your controller and the code, the business code, the logic that's actually going to satisfy that request for the user. So all the queries and algorithms, whatever has to happen. So the good news is it adds a layer of indirection. The bad news is it adds a layer of indirection. So some projects, you don't need an additional layer of indirection. And in fact, it's really quite annoying to go into an MVC action and see, mediator.sendAsync, now I have to go find where that happened. But if you're in an application where you need this decoupling, perhaps you're inducing logic that might not be in the same project, or you have to reuse some of the logic between the controllers, Mediator can be a great way to make your controllers very skinny. So they're not going to be initiating any database queries, or they're not going to be doing any web service calls. All of that is going to be in code that is eventually reached when you send a request through Mediator. And if you're building an API, a lot of people still build API controllers inside of projects that use cookie authentication. So just remember, if you have cookies to authenticate users, you have to check for and validate anti-forgery tokens, and that goes for API controllers also. So then the question becomes, when I'm doing a post to my APIs from JavaScript, how do I get an anti-forgery token that JavaScript can use when it sends something to my API so we can validate everything? And this is just an example of a cross-site request forgery token controller that someone can just do a GET request to /API/cserv token, and this will use the anti-forgery service in ASP.NET Core to get and store tokens. So there's two operations happening. The one is very obvious. The one operation that's happening is get and store tokens will return a data structure that we can serialize down to JavaScript to say, here's the token that you have to place into every request, or at least every post and put and delete request when we need to validate a token. That's the token value, and this is the name of the header that you should place it into. Because ASP.NET Core, if you put validate anti-forgery token, put that attribute on an API controller that receives a request, it'll look in the header also, as well as for a hidden form input. But if you're doing from body, it'll look in a header. And the other thing it does that's not quite as obvious is the store bit, which is if the cserv token cookie hasn't been issued as yet, that will initiate a set cookie to send the cookie down to the browser that is compared to the token to make sure we don't have a cross-site request forgery. So that allows JavaScript to work with that. Something else in ASP.NET Core is to embrace security policies. It was really difficult for me to understand what was happening in ASP.NET Core security until I went into that security repo and started working with some of the samples in there. We could do a whole session on ASP.NET Core security, but it basically revolves around very simple things. There's claims. A collection of claims represents a user. So the claims, you probably know, are like key value pairs. It could be first name is Scott, is admin equals true, last name is Alan. That would be the claims that are issued by some identity provider. And then when I went to, and permissions could be claims too. So I could have something like can edit invoice, true. That could be a claim. Then I have policies. Policies, one of the things you can do is have requirements that check those claims. So what I like to do inside of applications is we still use the authorize attribute in ASP.NET Core, but when you're trying to work in an application that has fine-grained permissions, I like to build policies, which are very simple. So this is going to create a policy named isAdmin, and the policy will require a claim for a user that isAdmin equals true. So I now have a policy that I could apply either using the authorize attribute and specifying policy equals isAdmin, or building my own custom attribute, user isAdmin, which derives from authorize and specifies the policy name. So now, developer just has to slap user isAdmin on a controller when only administrators are supposed to be able to get into that controller. Talk about views. If you're coming to ASP.NET Core and you're still using HTML helpers, try to wean yourself off of them. They're actually the worst feature of ASP.NET MVC, I always thought. And there's still some that you have to use, but for the most part, any place where you're using things like HTML.BeginForm or HTML.TextBox or HTML.Input, get rid of that stuff because they're really ugly. They don't blend into the HTML, so use tag helpers wherever you can. So ASP-4. That's a tag helper that's useful in a variety of scenarios. You can use it for labels, so it'll pull out the display name for a particular model property, like name. You can use it for inputs. It works the same as an HTML helper. It just blends into the HTML better. But it uses the metadata provider to go out and find information about this property. It knows its type. It knows its name. It can set the type of the input. It can add the validation attributes there for client-side validation. So HTML helpers are good. You can write your own HTML helpers. It's not too difficult. How difficult could it be? You just derive from a base class called tag helper, and there's a process method that you override. So you can build your own tag helpers that are processed server-side to do interesting things, custom things for your application, which is also the case for view components. I like view components very much, particularly in those applications where you might be rendering server-side HTML, and you might be building a page that is composed of pieces from different microservices. So you might have one of those pages where there's 4 things on the screen, and they all come from completely different units of the business inside of your application, kind of like some of the Amazon screens where they're pulling stuff for today's deals and the things that you like and things that are in your shopping cart. But if you haven't looked at view components in ASP.NET Core, they're very simple. They are very much like controllers in the sense that this is called a main menu view component. So the name of the component, I would think of it as main menu, just like the home controller is the home controller. It derives from a base view component. The difference between view components and controllers is that view components never get invoked via a URL. So they are only rendered when someone else tells them to render as part of a view. So they have one method, invoke. And then it can be invoke async also and return a task. Dependency injection works, so there could be a constructor here asking for services, data access services, other API services, building a model, returning a view, and you can render them, not with that syntax, that's ugly. You can render something like that with this tag helper syntax, actually, view component : main dash menu. So it gets kebab cased, where capital letters, they all become lowercase, and there's dashes between the capital letters. But view components are a nice way to build a compartmentalized UI. So you can have 4 independent view components on that page that renders 4 different things, and none of them know about each other. They all do their own thing, and they can even do their own thing in parallel, which is kind of nice. Let's talk about client code. When I say use Webpack, I think what I'm really saying is if you haven't jumped on to ECMAScript 2015 and above or TypeScript, it's really time to do that, unless you're writing a trivial amount of JavaScript. But to me, Webpack and ECMAScript 2015 features, when they came along, the ability to write modular JavaScript and be able to say things like import foo from bar was wonderful. Webpack does have a little bit of a learning curve. I think it's gotten better, and the documentation certainly has gotten better over the years. This is an example of a Webpack configuration file where I'm basically saying I want to build an entry. So I want to build a file called vendor that consists of all the modules for third-party code that I use: React and React DOM and React Bootstrap and Axios and ES6 Promise. And what Webpack will do is go into the top level of each of these and study the import statements and keep gobbing up modules and producing a single output, a .js file, because it's also run all this stuff through a transpiler if need be. And then there's plugins to do things like minification. And these days you can even strip out dead code and so forth. One of the other things to keep in mind if you write Webpack configuration files is you're not writing a configuration file in the sense that it's just static data. It's not a JSON file. When you write a Webpack configuration file, it has a .js extension because it's actually code that's going to execute inside of Node.js. So if you have complicated things going on in your build process that Webpack needs to handle, you can write code to do things like, let's go out and glob up all the files that have the extension .specs.ts and put that into a collection, and then concatenate all the specs from a different folder, and then run some really ugly regular expression, which I can't even remember what that does anymore, but I'm sure it's significant. I'm going to skip this slide for right now, but I'll talk about it. So Steve Sanderson, one of the things he did before he started working on Blazor was implement this project called JavaScript Services. So if you're using Webpack and TypeScript and you're doing all these things, you typically have a lot of command prompts open to do your transpiling and run your unit tests of JavaScript. Sanderson's project, JavaScript Services, if you take a look at that GitHub repo, has some interesting middleware that you can add into your pipeline when you're inside of development to sort of hide Webpack behind the scenes. And what this allows you to do is instead of opening up command prompts and telling Webpack to run and getting all this stuff set up, you just have your configuration files out there, you put this middleware in there, and on the first request to the website, this piece of middleware will communicate with Webpack and start Webpack up to start watching your files and transpiling your files. And when I go into a file and save it, Webpack will transpile it and load it right into the browser for me. So it's just a nice way to work with JavaScript these days when you need module bundling from Webpack, because it hides a lot of the ugliness that goes on behind the scenes. Requires less setup. I'm a big fan of Conemu or Commander. Anyone else use those? Oh, good, a fair number. So once you start doing a lot of things from the command line, you'll discover that the built-in Windows command line isn't really that great. So this is Conemu. You can do a Google search for that. Or sorry, this is Commander. Which one do I have installed? I always get them confused. Commander. You can do a search for it and find a download. One of the things I can do that's quite useful for me is I often have multiple contexts that I'm working in. So I can open up multiple tabs in this window and do different operations from different areas. So that's happening over here, and on this tab, something else is happening over here. So maybe an example would be like this, where in one pane, I'm running Webpack to transpile my files and watch as things change. Up here, I'm running tool to run JavaScript unit tests, and down here are integration tests that are running. So they're all in 3 panes and 1 screen. And I'll just point out that these tools are awesome because watch this. You can right-click this. You know this is a developer that wrote this for developers, right? If you go into the settings dialog, there's just hundreds and hundreds of settings. I only know what about 6 of them do, but there's a lot of power there if you take advantage of that. This screen, by the way, is set up using this command. So this is a way of saying, conemu. So let's start conemu and do an npm run watch in this new instance. But then I want to open up something else with npm run my test watcher, but put that in a new console that's split horizontally, and then run my Karma integration test in another console that is split vertically. And that's how we end up with those, 3 screens that you saw on the previous slide, that way. I also like, when it comes to things like feature folders, I also like, if I'm working with something like Angular, which I haven't actually in a while, or React, which is what I've been using lately, but not much. Let other people worry about it. I like to put components that are associated with a specific feature in the feature folder. So what we might be looking at here, what we're looking at here is a client folder where common stuff goes. So common models, common services, common components that get used throughout the application, like a toggle button. But over here, inside of a feature folder, there's a controller, there's a view that renders some HTML, and there's a component that is specific to that particular feature. So it's this isn't a spa. It's one of those applications where you enhance certain pages by adding React components or what have you. And like I say, if I could put the unit tests in here also, I would love to do that. My C# unit test, just have everything together. If you're still using Bower or some of these other things, this slide is really, it took me a while to convince people, look, use just NuGet for .NET code. That part was easy. But what I mean by that is don't use NuGet to install jQuery or things like that anymore. And then just use NPM or perhaps Yarn, because that's the newest thing, to manage all of your JavaScript and TypeScript packages. So years ago, there was NPM for Node.js stuff, and then there was other package managers like Bower for the front-end stuff. These days, all the front-end libraries like Bootstrap and jQuery and Angular and React, they have everything inside of NPM. So that's the only package manager that I need to install anything that I need JavaScript-y. So I can use that to install the TypeScript compiler, and I can also use it to install Bootstrap and jQuery. And TypeScript. For years, I avoided TypeScript because it just didn't feel right. It felt like the Microsoft way of working with JavaScript. But when they started working with the Angular team, there was a number of wonderful things that came out of that. And today, I try to encourage people to start using TypeScript because it actually plays well in the environment. A couple examples would be things like this module resolution. 2 years ago with TypeScript, it was very difficult to encourage or convince TypeScript to work the way you wanted, so you could place the files, your files, where you wanted to place your files. You had to have them in specific locations. When they introduced module resolution that you could set it to Node, all of a sudden, that would allow you to do things like npm install something, and then inside of a TypeScript file, say import foo from bar, and TypeScript would actually use the node module resolution strategy to look for bar and find that module, and it would look inside of node modules, which was great. So it's all of a sudden TypeScript became a lot easier to use, and then this path setting, so this is a tsconfig file in case you didn't know, that controls the TypeScript compiler. This is a place where I can say, when someone says import foo from bar, yeah, you can look in node modules, but I also want you to look over here, client script. Look for that bar module inside of there too. So now I can completely control my environment, and I can lay out files the way I want to lay out files, and it's much easier to use now, unless you're using Visual Studio. So when I work on a project that has a lot of JavaScript, I have the project open in 2 editors. Visual Studio Code, definitely, for the JavaScript, and then Visual Studio Code is also a great editor for C#. But if there's things that you like in Visual Studio, you can have the project open in both editors. But I definitely do all my JavaScript inside of Visual Studio Code, and TypeScript also. There's not as many false positives, for one. And then I consider www root as the bin folder. So when Webpack does its module bundling and minification, and it spits out a build, or spits out my JavaScript, that's going to go somewhere inside of www root. Testing. So let me tell you a little story. About 4 years ago, I was working on an AngularJS project. So this is AngularJS 1.0. And I had come from a background where I started trying to do test-driven development in 2004. That's when I started. And from 2004 to 2014, I kept trying to do TDD and unit testing. I'm learning things all the time. And I have to say, I think TDD is a great way to learn unit testing. And TDD is a great way, it's a great way to design things. So if I'm entering into a domain that I don't understand what the solution is going to be, I love to using TDD to figure out a solution to a problem. And what I mean by that is if I'm writing an ASP.NET Core controller, I'm not going to TDD the design of the controller. It's just not much benefit to that. But I might unit test the controller. So up until 2014, I would still unit test the controller. So coming into this Angular project, I approached it like any large ASP.NET project I had done. So this is the largest Angular project I had ever worked on. I wanted to unit test every controller. And when I unit tested an Angular controller, I wanted to isolate it, because that was one of the principles that I always followed. We isolate things. That way, if someone checks in some bad code to a low-level component, it doesn't break all the tests. It should only break the tests related to that component. Everything is kind of isolated. So unit testing these Angular controllers involved, let me skip that, writing a lot of, let me skip that, mocks and fakes and stubs. So every service that is passed into that Angular controller, I would fake something up in a unit test, and I would test just trying to isolate the controller. Me and 3 other people. And what we discovered after a few months of this is that we were still getting a lot of bugs in production because things were breaking. These unit tests, we were writing piles of code, and they were just not being as effective as we wanted them to be. So I decided to try something different. I said, let's not fake or stub anything. Let's write test code. And there was a big debate about, is it a unit test or an integration test? I don't care. It's just test code and not fake anything. In AngularJS, there was this interesting ability to cut things off at the HTTP layer. So you could write a test that instantiated a controller, invoked a method. It would use all the real services. So the controller would call service A would call service B would call service C, and then service C uses the HTTP service to try to call an API. Well, there was a fake HTTP backend that you could use in Angular to say, okay, if someone makes a request to /API/invoices, return this JSON. So we started testing all the controllers that way. And what I discovered was we were writing probably 10% of the test code that we were writing before, and all of a sudden the test code became very effective. Like we were actually finding problems when someone changed the behavior of a service. And it was a complete revelation to me. It's like, oh, all of a sudden I'm writing a lot less test code, and I feel like I'm getting more bang for the buck. And yes, there's the situations where someone checks something in that is just so wrong, or I do something when I'm developing that is just so wrong and breaks every test. But that's okay. I'll figure out what the problem is. I don't need tests to tell me how to debug something. So fast forward, I come off that project and I'm starting to look at ASP.NET Core and work with ASP.NET Core, and I'm starting to think about, these controllers, do I really want to isolate them when I test them? It's always such a pain. Well, there's 2 things in ASP.NET Core that I found interesting. One is the ASP.NET Core test host. So if you go into the Microsoft GitHub repositories, when Microsoft wants to test their middleware or do some, let's call it integration level type testing, they have a NuGet package that they install into their unit testing project called Microsoft.ASP.NET Core.TestHost, and it basically allows you to spin up your application and run it in memory and fire off requests at your application without anything ever actually going over a network socket. So This little bit of code is just a way, well, there's some encapsulation here. Like, it's not just as easy as saying create server, but create server behind the scenes uses some abstractions from test host, just a few lines of code to create a server that will have an application inside of it, and now I can start sending off requests, and I can write asserts based on the HTTP message that comes back from that request. Here's another example. Create a server, send off a request to /normal. I want to get a 200 status code back. To me, that was very interesting, particularly combined with the fact that with HTTP clients, it's relatively easy to use delegating handlers or message handlers, or basically to have an in-memory HTTP client. And if you're using Entity Framework Core has an in-memory provider. In other words, just like I did with Angular, there's ways in ASP.NET Core to sort of cut things off right at the data layer and really focus on state-based testing, writing unit tests that are more of integration tests that sort of flow through the whole application and just reach, in this case, perhaps a fake database that's in memory, so the tests execute really fast. So the EF Core, we could debate whether it's still a great technology or not, but the in-memory provider for the applications that I've worked on that use EF Core has been very beneficial. It's very easy to set up the entity framework and basically tell it use an in-memory database. So is it like SQL Server? No, because I can't remember specifically if it enforces things like non-null primary keys. I mean, you can do things with the in-memory provider that you cannot do with a real SQL Server, so it doesn't catch everything like foreign key violations. But it's close enough and allows me to do state-based testing. And I can write tests like this. So this is a test that's just going to instantiate a controller, pass in some input that the user probably filled out in a form, and we're just going to run through the whole thing, all the regular services it uses, and just make sure it produces the right result. And to me, that's a beautiful test because there's not a lot of code there. It's easy to read. And even better, I can go into the system and refactor things all I want, change services around, and move things all over the place. And the chances are I won't break that test, and I won't have to change this code, right? I won't have to go in and change a bunch of mocks and fakes and stubs that I've implemented. So for me these days, I'm more big on integration tests, not at the UI layer, but things that test multiple components at once and get the most bang for my buck for my testing code. Let's talk about C# code. A lot of people are getting into .NET Core because they want to be able to write web applications in their favorite editor and favorite operating system, but then host it in the cheapest possible operating system. So quite often those two things are different. You're writing on Windows and deploying into Linux. So these are just a couple things that we ran into. So I do want to also say that if you're in that scenario, you should strongly consider Docker, because then you can be working in your Windows environment, but actually working in an application that's running on a Linux Docker container on your machine, and you can catch code, you can catch problems early. But you want to make sure when you're writing C# code that you're not making assumptions about the operating system. So we had people getting caught with hard coding /r's and /r's/n's inside of source code. You want to use environment.newline because that will return the proper newline character for the operating system that you're on. Another big one was developers doing some directory plus /file.txt and combining strings together themselves to build a path where there's. Instead, you should use path.combine to make sure you get the correct folder separator, directory character. In fact, the directory class in .NET has a separator char property that you can use that will return the proper separator for the operating system that you're on. And just also, if you're using environment variables to discover things about the operating system, like the home folder for the profile or the service identity that you're running under, those can be different too. So sometimes you have to use expressions like this to make sure you get both Windows and Linux. And then something else I've been railing against, that again, another opinion about writing C# code, I don't like the async suffix anymore. So when I write code that is when I write an async method, I will call it sign out tenant user. And of course, when I invoke the APIs that Microsoft provides, I still have to have the async keyword there. But to me, it's enough to have the async keyword here. There's already async and await, and there's async. And when you have async code bases, you probably know there's async just ripples up and down the place. It's all over the place. And I felt bad about this for a while because it made people irritable that I was going against the coding conventions that everyone else is using. But then I read this interesting interview with Bjorn Strustrup, who said basically, whenever there's a new feature added to a language, programming language, people want loud, explicit syntax. And I think that's what happened with async. When Microsoft introduced async await, it's dangerous. Is that creating a thread? I don't know, but it could cause problems. So let's make it loud and put it in people's faces that this is async. But now we're kind of used to it, and we want a terse, or at least I want a terse notation. So, if C# version 9 just assumed if there was some flag on the compiler where you could say, look, just assume everything is async, and I can get rid of all these keywords, man, that would be great for me. Anyways, that's my email address if you have questions or you want access to the slides or things like that, and have a good evening.